There's a group of men and 5% of them, they are under 60 inches of height. Okay, and 40% of them, they are between 60 and 65 inches of height. Clear? You have to assume that x, which is the height of men, is normally distributed with mean mu and variance sigma square. Okay, now what you are given is when px is less than 60, it is 5%, which is 0.05. You're also given that p60 less than x less than 65 is 0.40. Okay, now what you're also given is you will have to locate it here on the diagram properly. So well, this is the mean of the distribution. This one here, this is x equals to mu. We have to calculate that x is equal to mu. Now you know this, that mean and median of the normal distribution, they are equal. In fact, mode is also equal. Mean is equal to median for a normal distribution. You also know this, that this probability is half and this probability is also half. Okay, so it is dividing the entire thing into 50% of region. Okay, now other thing is px is less than 60 when x is equal to 60. Say for example here, this one, when x is equal to 60 here, this region is basically what? How much? 0.05. This region is 0.05. This region. Fine. So this is what you have told here. And between 60 and 65, let's say this region is between 60 and 65. So this region is how much? 0.40. That is 40% of data lies here. This is 0.40. Clear? Now, what does it mean? That between 60 to 65, 40%. Below 60, 5%. So below 65 is how much till here? 45%. That is 0.45. Okay. Then between 65 and mu is how much? 0.05. That is 5%. Is that okay? So how could you write this? That p65 less than x less than mu is how much? 5%, which is 0.05. Is that okay? Other thing which you also have to understand is that whether you write px less than 60 as 5% or you write p60, I'm just writing it again here with a different thing. If you write px less than 60, okay, as 5%, 0.05, okay, then what does it mean? That between 60 to mu, how much is the region? 45%. Okay, so you can write between 60 to mu, the region covered is 45%, which is 0.45. Is that okay? So what you have to do is that you have to convert these two equations now into a standard normal variate. What is a standard normal variate? Standard normal variate is z, which is given by x minus mu upon standard deviation, where z is normally distributed with mean 0 and variance 1. So when x is equal to 65, I'm converting the first one first, which is, I'm again writing this out, p65 less than x less than mu is 5%, 0.05. So when I converted that into a standard normal variate, when x is equal to 65, so z becomes 65 minus mu upon standard deviation is less than x when x is equal to x, so standard normal variate becomes x minus mu upon standard deviation is less than when x is equal to mu, so standard normal variate becomes 0. This probability is 0.05. Clear? Now for the second one, which is P60 is less than x is less than mu. Okay, so P60 is x is less than mu is what? 0.45. Well, you can write this as P. When x is equal to 60, this would mean 60 minus mu upon standard deviation. When x is equal to x, standard normal variate is x minus mu upon standard deviation. When x is equal to mu, then standard normal variate is 0. This is equal to 0.45. What does these two imply? That you will have to figure out these probabilities. Okay, well, one more thing which you have to understand is, if you write 60 minus mu upon standard deviation, or you write mu minus 60 upon standard deviation, that would mean same. So I can convert this equation again into P 0 is less than x minus mu upon standard deviation is less than mu minus 60 upon standard deviation. This should be equal to 0.45. Okay, now I need to get the values which from the normal tables which have given me these probabilities 0.05 and 0.45. So let me just find it out. 0.05 is this one. Approximately 0.05 is this, which is 0.13. Okay, so 65 minus mu upon standard deviation, or even here, whether you write 65 minus mu upon standard deviation, or you write mu minus 65 upon standard deviation, that would mean same, which is P is 0 is less than x minus mu upon standard deviation is less than mu minus 65 upon standard deviation. This would be equal to 0.05. You already have gathered till now, which is mu minus 65 upon standard deviation is 0.13. Now we need to find out the numbers which have given us the probability of 0.45. 0.45 is somewhere here, which is 0.4505, which is 1.65. Okay, approximately. So that would mean mu minus 60 upon standard deviation is 1.65, or you can approximately write 1.645. Okay, and if you calculate, now these two are the equations in two variables, which is mu minus 65 is equal to 0.13 sigma. Another one is mu minus 60 is equal to 1.645 sigma. If you calculate it, you'll be getting sigma is equal to 3.29 and mu is equal to 65.42.